All right, everyone. I hope you're having a good week. I need you to pull out 2 sheets for this video. It might say MDR or it might say PNL or preparing for the next lesson for 4.5, depending on which sheet you grabbed. And then the lesson, grab one of those, the lesson on 4.5 called Breaking Down Variables. So the P&L, obviously, we would do in class, and you guys would work on it a little bit, but let's just kind of play with it together. It's a short one. So this is a nice cylinder or a can, and the formula for volume of a can is the area of a circle times the thickness or the height. So take a minute, pause the video, and see if you can figure out the volume of this can, given the parameters that it has a radius of 9 feet and a height of 25 feet. And then you want to round it to the nearest cubic foot. So pause the video and plug those values in. Pull out your calculator and see if we get the same thing. So I'm going to start. The radius is 9 and the height is 25. So we've got pi times 9 squared times 25. And we're going to change that so we can get a number that we can round. So rounded to the nearest foot, that 1 is going to become a 2. So we'll have 6,362 cubic feet. Okay, another little review question is doing some conversions in those bunny trails. So it says many states have banned texting while driving because it's dangerous, right? You don't realize just how far you travel when you aren't looking at the road when you're going down the highway. So it says, suppose you're driving 65 miles per hour. How far are you traveling in feet per second? And then we'll figure out how far we'll be driving if our eyes look away for 3 seconds. All right, so let's see, we're going 65 miles per 1 hour. Now on the final and on the test, this is set up for you like that. And then you have to fill in the missing places. So if we convert miles to feet, that conversion will be given to you. So I'm going to put miles on the bottom and feet on the top. And then they're going to get rid of, we need to get rid of hours. This is the one thing you have to memorize, that in 1 hour, there's 3,600 seconds. So we're converting this from miles per hour to feet per second. The miles cancel, the hours cancel, and we're left with feet per second. So let's go ahead and plug this into our calculator. We have 65 miles over 1 times 5280 over 1 times 1 over 3,600. So it looks like we're traveling 95.33, round it to the nearest hundredth, feet per second. Now if we take our eyes off the road for 3 seconds, then we're going to take that 95.33 feet per second and multiply it by 3 seconds. Okay, so we're going to take that 95.33 and multiply it by 3 seconds. Let's round that to 286 feet. Round to the nearest foot. So 286 feet. That's a lot of feet to be traveling in just 3 seconds. So the back page is nothing but reading. So I just want to describe what they're talking about here. So in the section that follows, we're going to be talking about braking distance. And one thing that they highlight is they're talking about what's called the grade of a road. So the grade is something that you've probably seen. I might have seen grade signs. Here, let me see if I can find one. I was running over the summer, and there was a nice road grade sign. Let's see, right here, just like this. This was up near Branchport when I was running. So you see this truck, and it's going downhill, and that says 8% grade for 1 mile. Okay, so what does that mean? Let's look at this. 8% is 8 over 100. That's what percent means. That's a slope. That's a rise over run. So they're telling us that there's a change in the road. It would be really nice if that said -8, because this line is going, right, this truck is going downhill. So it's going down this direction. But anyway, the truck's really going downhill instead of going uphill. But 8% means rise over run. So that means this, like this, right? So if there's a truck, see how it's going down? So if it goes 100 feet this direction, it's going to fall 8 feet this direction. So it's just a warning to trucks, right? That they've got to put their vehicle in like a low gear because they might not be able to brake quickly because they're going downhill. So like this was saying that there's a 12% grade. So let's do it. Let's do the rise over run. So they said if a truck is going to go down 72 feet, if they drive out 600 feet this direction, well, rise over run. If we pop that into our calculator, the sign simplifies. So to convert that to a percentage, you multiply it by 100. So that's why the sign says a 12% grade, because it's simplified, right? Look at this. So 72 over 600, right? So you go down 72 feet if you run 600 feet, right? Rise over run. And if you pop that into your calculator, you get that. And if we multiply it by 100, then we can write it as a percent. They don't put the negative sign in, but we know that it's for downhill travel. So that's what's called the grade of the road. And we need that for the next section. Okay? So pull out your 4.5. And we're going to look at a new formula. It's kind of like the blood alcohol content formula. This formula deals with what's called braking distance. So say you're driving and you slam on the brakes. Your car doesn't stop right away. It has what's called a braking distance. It's the distance a car travels and the time between when the brake is applied and when it comes to a full stop. Okay, so my other class talked about the variables that might affect braking distance. And of course, someone said the grade of the road. So if you're going uphill and hit the brake, it's not going to take as much time for you to stop as if you're going downhill. So the grade of the road impacts braking distance. Around here, especially, the conditions of the road. That will affect braking distance. So if it's icy versus a dry road versus gravel, right? So there's all these types of roads around here. That would be road condition. Another thing that will impact braking distance is how fast you're driving. Right, that's a very good thing to keep in mind, that if you're going really fast and you slam on the brakes, you're not going to be coming to a complete stop anytime soon. And then another thing that they talk about as possible factors, it's what's called friction. And that kind of goes along with road condition. So when they talk about friction, they're talking about how good your tires are. And that kind of gets hooked up with road condition. So there's this letter that's called little f that talks about how your tires, ride on the road. So if you have really good tires and the road condition is really good, then this F value will be close to 1. So that is called the coefficient of friction. The closer you are to 1, the better, the quicker you will be able to stop. Okay, so let's look at the formula. See how all these come into play. So D is braking distance. V is velocity. It's how far you're driving, but you have to keep in mind that it's in feet per second and not miles per hour. All right, D is braking distance in feet. G is the roadway grade, right? So that's how steep the road is. It's positive if you're going uphill, and it's negative if you're going downhill. Okay, and then this little is the coefficient of friction between the tires and the roadway. And I said if you have really good tires and the road is dry, then F will be close to 1. But if you're on bald tires and an icy road, then you're close to 0. And then, of course, we have gravity, right? Gravity is pulling us towards the earth. So that is a constant. It never changes. They will give that to you on the final or on the test. And that's 32.2 feet per second. All right, so the first thing they want us to do is they want us to rewrite this formula so it looks a little simpler on the eyes. So they're telling us that little f is 0.8 and that g is 0.05. So if we plug those into this formula, we've got f is 0.8 and big G is 0.05 and little g is always this value right here. So let's multiply the 32.2 with the little g. And then we'll put our parentheses, and then we have 0.8 plus 0.05. So do you see we have nothing but numbers downstairs in that denominator? So let's plug those numbers into our calculator and make it look a little simpler on the eyes. So 2 times 32.2 times, and then there's parentheses, 0.8 plus 0.05. See, I put everything into my calculator as I see in the denominator. And so now I'm going to rewrite this formula as D equals velocity squared over 54.74. Okay. So what they're going to ask us is, how do we find braking distance for all of these speeds? Now in my other class, I flipped this and I changed it. I said, let's compare 35 miles per hour to 70 miles per hour. Here, they doubled the speed, and we're going to see how that impacts the braking distance. And then we double the speed again from here to here, and let's see how that impacts the braking distance. So we need some scrap paper, because in order to use this formula, we need the velocity to be in terms of feet per second. It's like what we just did. We just did this on the P&L. So we're going to set up a little bunny trail. Okay, you ready? So if we're going 10 miles per 1 hour, what I want you to do is I need you to turn off the video, fill in these places, and then figure out how fast you're going in feet per second, and then round it to the nearest tenth. So we want our answer to be in feet per second, not in miles per hour. Okay, so pause the video and look at the notes you just took on the P&L or that MDR and see if you can figure this out. Right, so in 1 mile, you should have written 5280 feet. And then in 1 hour, we put hours on the top because we want to cancel. We'll travel 3,600 seconds. So you see our hours will cancel and our miles will cancel. So let's see how fast we're traveling if we're going 10 miles per hour. How fast are we going in feet per second? Just typing that into my calculator. I'm not changing a thing. It looks like we're traveling 14.7 feet per second. So let's put that in our table. And now we can figure out what our braking distance will be. We're not traveling very fast at all, so it shouldn't take us long to brake and then come to a complete stop. So my braking distance is velocity squared all over 54.74. So how long will I travel before the car comes to a complete stop? Looks like I'll only travel about 3.95 feet, not even 4 feet. So let's repeat. Okay, I'd really like you to stop the video if you can, and then repeat this for 20 miles per 1 hour. Okay, so you look at the work upstairs and see if we can figure out, if we're going 20 miles per hour, how fast are we driving in feet per second? Okay. So I'd really stop the video and see if you can do this on your own, so that your miles will cancel, your hours will cancel, and then you're left with feet per second. Okay, so I'm going to plug this into my calculator. So it looks like we'll be traveling 29.33 feet per second. Okay, so let's see how fast it will take us to come to a complete stop if we're traveling 29.3 feet per second. So we've doubled our speed. Before we were going 10 miles per hour, and now we're going 20 miles per hour. So if we double the speed, do we double the braking distance? That's the big question. If we double the speed, do we double the braking distance? It looks like it's more than double. What's 15.68? How many times larger is 15.68 feet compared to 3.95 feet? It looks like it's close to 4 times. So it looks like if we double the speed, the braking distance is 4 times larger at the faster speed. If we double the speed, we more than double the braking distance. The braking distance is 4 times larger when the speed is doubled. Let's test it. Let's try it for this one. So if we go 35 miles per hour, what's our braking distance? And then let's compare it if we're going 70 miles per hour, which is double that. Okay, so really pause the video and try to do these two on your own. Okay, pause the video and see what you can make of this. All right, I'm hoping you've done this on your own first, and then you can check. It's the same things that we just did. There's nothing new. Right? If we want to get rid of miles, and miles is on the top here, then we have to put miles in the denominator for that second fraction. Hours on the top, so we can get rid of hours. And now we're left with feet per second. So if we're traveling 35 miles per hour, how fast are we traveling in feet per second? Right, this is 51.33. They didn't really tell us what to round it to. We can do 33. So 51.33 feet per second. That's how fast we'll be traveling if we go 35 miles per hour. So let's figure out what our braking distance would be. So we're going to take, for this one, 51.33 squared and divide it by the 5474. Remember, that's our formula right there. So 51.33 squared, and that's on the bottom, or on the top of the fraction, and then 54.74 is in the top. Oops, forgot my decimal. So our braking distance is 48.1 feet. And now let's repeat for 70 miles per hour. Let's pull out our scrap paper. So if we're going 70 miles in 1 hour, that means in 1 mile, I'll travel 5280 feet, and then in 1 hour, I have 3,600 seconds. So the hours cancel, and the miles cancel. So let's go ahead and see how far I'm traveling in feet per second. Okay, looks like 102.6 feet per second. I'll have to say 6-7 feet per second. Right, just round it out a little bit more. They weren't specific on how far we needed to round. And then to figure this out, we're going to take that velocity and put it over that simplified version of the denominator, right? So that braking distance is 192.57 feet. So if we double the speed, do we double the braking distance? I think this is much more than double, right? If I double 48, that's not even 100. This is well over 100. So how many times further is the braking distance compared to the braking distance if we don't double the speed? So this is double the speed versus not doubling the speed. How many times larger? What's big over little? We got 4 times before, and you see we get 4 times again. So if we double the speed, we quadruple the braking distance. I'll write that down so we'll remember it. If we double our speed, we quadruple, that means times it by 4. Quadruple our braking distance. The distance we travel after we hit the brakes till we come to a complete stop. Right, so that's a shorter lesson. There wasn't too much new. They will give you this formula on the final, but they also give you all of this on the final, so you don't have to memorize any of this. The only thing you have to memorize is how many seconds are in an hour, okay? It's the only thing that you've got to remember when you're doing these kinds of bunny trails. I call them bunny trails, right? To go from miles per hour to feet per second. All right, now the Lumen is open, and there's not many questions, but they're kind of tricky. The last 2 are tricky. So if you're having any trouble, keep in mind that the Friday we come back after that week, we'll have that day to do a recap and then answer any Lumen questions that you might have, okay? And then the following Monday, we'll review for the test. On Wednesday, we'll take the test. And on Friday, we'll review for the final. All right, I hope you're having a good break week.